The topic is rounding and estimating. The objectives in this topic are round whole numbers, use rounding to estimate sums and differences, and solve problems by estimating. So rounding a whole number means approximating it. So here's a number line, a line with numbers on it, and there's a dot on that number line at 26. 26 is closer to 30 than it is to 20. So 26 rounded to the nearest 10 would be 30. Literally, the two closest tens to 26 are 20 and 30. It's between them. Which one is the nearest 10? Rounding to the nearest 10 on a number line literally physically means which is the nearest. And it's nearest to 30. A number line with a point at 52. The nearest tens to 52 are 50 and 60, and we're closer to 50. So 52 rounded to the nearest 10 is 50. So it looks like if we're on the right side, we go to the right. If we're on the left side, we go to the left. But what about if we're exactly in the middle? If we look at 25, which is halfway between 20 and 30, it's not closer to one or the other. In such a case, the rule is that we round to the larger 10. Round up if you're right in the middle. So we round 25 up to 30. In general, the procedure to round whole numbers to a given place value. Step 1, locate the digit to the right of the given place value. If this digit is 5 or greater, add 1 to the given place value and replace each digit to its right by 0. If it's less than 5, replace it and each digit to its right by 0. No adding 1 to the given place value. And rounding's not bad at all. You probably already know how to do it, but we're going to go over it anyway. Let's start with a number like 242. And we're going to round to the nearest 10. So the rule is we find the tens place value. Ones, tens, hundreds. So we underline the tens spot. And then we look at the digit to the right. The digit to the right of the 10 spot, because we're doing nearest 10, that's going to be what determines if we round up or round down. A 5 or above in the spot to the right rounds up. A 0, 1, 2, 3, or 4 rounds down. So here we have less than a 5. So 242 goes to the nearest 10, which would be 240. Visually, what's happening here, what are the tens around 242? We would have 240. We would have 250. Visualize where 242 would be. It'd be closer to the 240. Literally, 240 is the nearest 10 to 242. Still nearest 10. Let's look at 585. Ones, tens. Look to the right. It's a 5 or above, so it rounds up. The 8 goes up to a 9, and everything else gets replaced by 0.
So the 5, that's the one where if you visualize it, it would be right in the middle. If it's right in the middle, the rule is it goes up to the next one. 580, 590, 585 would be right in the middle. Let's do a nearest 100. For the number 8,189. Well, we find the hundreds spot. Ones, tens, hundreds. We look to the right. That's going to round this up to a 2, and everything after becomes a 0. This would be between 8,100 and 8,200, and we don't say that way. What did we learn last time? 8,100, 8,200. This would definitely be closer to 8,200. 8,200 is the nearest 100. Let's go back to another nearest 10. This time, let's see what happens when we have 498. Ones, tens is right here. If we look to the right, that 8 tells us we're rounding up. So what does the 9 become? To visualize that the 9 rounds up to 10, the 9 becomes a 0. That's the 0 from the 10. Where does the 1 go? And then we add 1 to the 4. So it rounds up to 500. And again, this makes sense. What are the tens around 498? 490 and 500. And it's definitely closer to 500. 500 is the nearest 10. How about 72,369? This one to the nearest 1,000. Just because it's now the nearest 1,000 doesn't mean we do anything different. Find and identify the thousands spot. Ones, tens, hundreds, thousands. Look to the right. Is it a 5 or above? No. So it rounds down. The 2 stays a 2. It doesn't drop down to 1. Rounding down is called that because the 369 comes down to 0, 0, 0. Again, what are the nearest, or what are the thousands to the left and the right? We would have 72,000. We would have 73,000. And this, because it's under 72.5, is closer to 72,000. 72,000 would be the nearest 1,000. The last rounding problem we are going to do together, though, $79,991. Let's round it to the nearest 100. So if we're rounding it to the nearest 100, tens, or ones, tens, hundreds, look to the right. It's a 9, which is going to bump this up. But since that's a 9, it's going to bump that up. And since that's a 9, it's going to bump that up. That becomes an 8, and everything else got bumped up to 0, and then these ones become 0. If we were rounding to the nearest 1,000. Ones, tens, hundreds, thousands. Look to the right. Rounds this up to 10. That becomes an 8. Same answer. To the nearest 10,000. This rounds up. Same answer. What about to the nearest 10? Ones, tens. That one would not round up. Nearest 10. Would be 79,990, which again is not how we say that number. 79,990. 990, not 79,990. And is going to be reserved for speaking decimal names, something that we're going to do down the line. If we had 61, 86, 26, and 74, and we were adding them all together. Remember, this, we could add the 6 and the 4 and get 10, 11, plus 6 would be 17. Carry the 1. Wow, this is so detailed. So many numbers. 1 and 6 is 7, plus 8 is 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 247. What if you didn't need the exact answer? What if you just wanted an estimate? Well, we can estimate the sum and not find the answer if we only need an estimate. So if it says estimate, it'll give you some additional information. Estimate the sum, let's do it by rounding each number to the nearest 10. So the nearest 10, we'd be looking at the 1 spot to determine if it rounds up or down. 61 would round down. 86 would round up. 26 would round up. 74 would round down. Add a bunch of zeros, you get 0. 6 plus 9 is 15. 16, 17, 18, 19, 20, 25. And what was, I erased it and I don't remember, so I'm going to cheat. Don't tell the teacher. 247 is the exact answer. So that's darn close. And that's what you want an estimate to be. You want it to be darn close. If you go to an auto shop and you ask for an estimate on your car and they say it's 250 and it ends up being 247, good deal. That's an estimate. That's what you want. You don't want them to say it's going to be 250 and then actually charge you 793. That's not a good estimate. So good estimate is close to the exact answer. We can estimate with subtraction. And since subtraction has all that weird borrowing stuff in it, this, again, I'm going to cheat because we don't want the actual one here. The answer here is 75. Let's estimate by rounding everything to the nearest 10. This would round up. That would round down. 5 minus 7 can't do it. 15 minus 7 is 8. Very close. In fact, it's good to the nearest 10. Can't get much better of an estimate to the nearest 10 than actually getting it to the nearest 10. So you'll have some estimation problems. And I want to make this clear. If it's just a subtraction problem, you can't just decide you want to estimate. The problem actually has to say estimate. But it'll tell you whether to round things to the nearest 10, to the nearest 100, maybe to the nearest 1,000, depending on how big the numbers are, in order for you to get an estimated sum.
Next, let's estimate the sum by rounding each number to the nearest 100. So the nearest 100, we have the 1s, the 10s, the 100s. This would be 2,000, 2,000, and 2,000. Here, the 0 has a 1 to the right of it, so the 0 does not round up, 2,000. Here, the 0 has a 0 to the right of it. The 0 does not round up, so 2,000. And here, the 9 has an 8 to the right of it. The 9 does round up. The 19 bumps up to a 20, 2,000. Why would we want to do that? Well, 2,000 plus 2,000 plus 2,000 is 6,000. So that gave us an estimate of the sum that did not require us to actually add these numbers. By the way, if we actually did add these numbers, we'd get a 5 and then a 9 and then a 9 and then a 5, 5995, which is awful close to 6,000. So an estimate is a close estimate, but it's not exact. Jared Nuss scored 89, 92, 100, 67, 75, and 89 on his biology tests. Round each score to the nearest 10 to estimate his total score. So we won't get exact. So we won't get this exact sum, but we will look at the sum of 90, 90, 100, 70, 80, and 90. Rounds up, rounds down. Stays the same. Rounds up, rounds up, rounds up. It's a little easier because we have a row of zeros, but 9 plus 9 is 18, plus 10 is 28, plus 7 is 35, plus 8 is 43, plus 9 is 52. So 52 with a 0 to the right, 520. Tasha Kilby is trying to estimate how far it is from Gove, Kansas to Hayes, Kansas. Round each given distance on the map to the nearest 10 to estimate the total. So we start in Gove. Maybe it's Govey. I've never heard of either of these cities. From there to Grainfield is 11. From Grainfield to Quinter is 16. From Quinter to Wakeny, is 19. And then to Hayes is 31, all in miles. Instead of an exact distance, we want an estimated distance. So round each to the nearest 10. So we take our actual distances and we round. The 11 goes to 10. The 16 goes up to 20. The 19 goes up to 20. The 31 goes down to 30. 10 plus 20 is 30, plus 20 is 50, plus 30 is 80. A lot easier to get to than the actual, but it's only an estimate. In 2010, there were 15,427 reported cases of chickenpox, 2,612 reported cases of mumps, and 27,550 reported cases of pertussis, or whooping cough. Round each number to the nearest 1,000 to estimate the total number of cases reported for these preventable diseases. So we take our actual amounts and we'd round each to the nearest 1,000. So 15,400 rounds down to 15,000. 2,600 rounds up to 3,000. 27,500 rounds up to 28,000. That's 18 and 28. That's 46. So the estimate is 46,000. A lot easier to get to than the exact, but it's only an approximation. And that's it for this topic. The topic is multiplying whole numbers and area. The objectives in this topic are use the properties of multiplication, multiply whole numbers, find the area of a rectangle, and solve application problems by multiplying whole numbers.
You need to know your multiplication table. At the very least, 1 through 9. And we make a multiplication table by skip counting. So if we skip count by ones, well, every one number is just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice how we read that. 1 times 1 is 1. 2 times 1 is 2. 3 times 1 is 3. 4 times 1 is 4. 5 times 1 is 5. It's just like Battleship. 6 times 1 is 6. Where did the row and the column meet? That's the answer. 7 times 1 is 7. 8 times 1 is 8. 9 times 1 is 9. We know anything times 1 is itself. We got another 1 down here. 1 times 1 is 1. 1 times 2 is 2. 3, 4, 5, 6, 7, 8, 9. Now let's skip count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. Just adding 2 every time. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12, 14, 16, 18. Skip count by threes. 3, 6, 9, 12, 15, plus 3 is 18, plus 3 is 21, plus 3 is 24, plus 3 is 27. Adding 3 every time gives us all of our threes because multiplication is just repeated addition. For instance, here, 3 times 5 is 15. Where do you think this word times comes from? 3 times, we have the number 5. 5 plus 5 plus 5. 5 added together, a total of 1, 2, 3 times. 3 times 5. Or 5 times 3. 1, 2, 3, 4, 5. Have the 5 or have the 3 5 times. That's also 15. So multiplication, the times is just telling us it's repeated addition. And that's why we can make a multiplication table by skip counting, by threes. 3 plus 3 is 6, plus 3 is 9, 12, 15, 18, 21, 24, 27. Now, you can't use a calculator, but at the beginning of every test time, you are able to, during the test, not before. You can't make it and then bring it to the test. But during the test, you're allowed to have your blank paper, and you can create this for yourself if you need it. But you really should try to memorize all the multiplication tables with your ones through your nines. Make flashcards. 1 times 1, 2 times 1, 3 times 1, 2 times 2, 2 times 3, 2 times 4, 3 times 2, 3 times 3, 3 times 4, all of them. And just try to get it so that you know these off the top of your head. But until then, you're welcome to make a multiplication table to help you out. No calculator though. 4 times 4 is 16 because we're skip counting by fours. 4, 8, 12, 16, 20, 24, 28, 32, 36, 20, 24, 28, 32, 36. And notice, since we're doing a column and a row every time, the space that's left gets smaller and smaller. So this actually gets easier to make as you go on. Skip counting by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45. 25, 30, 35, 40, 45. Counting by 6, 36, 42, 48, 54. 36, 42. Plus 6 is 48. Plus 6 is 54. Sevens, 49, 56, 63, 56, 63. 8, 64, 72, 64, 72, and then 9 times 9. If you add 9 to 72, you get 81. Okay, so you have this in your notes now. Go ahead and complete getting this written down. I am going to refer to this over and over again for the multiplication facts. But because you have this, I'm now going to assume you know any single digit number times a single digit number. And we will do multiplication now.
Multiplication is just repeated addition, but with different notation. For instance, if we had 6 plus 6 plus 6 plus 6 plus 6, that means that there's 5 6s. Or we have 6 5 times. 5 times 6. We're adding 5 times 6. That's why we say 5 times 6. The 5 and the 6 are referred to as factors, and the answer to a multiplication problem is a product. So 5 times 6 equals 30. 5 and 6 give us a product of 30. The times that x is called a multiplication sign. Now, get out of the habit of using the multiplication sign. You want to, whenever possible, try to use the dot instead. The dot also means multiplication. And we see that here in these multiplication properties of 0 and 1. So 0 was special with addition because anything plus 0 is itself. Both 0 and 1 are special in multiplication. 0 is special because the product of any number and 0 is 0. So 5 times 0 is 0. 0 times 8 is 0. It doesn't matter if the 0 comes first or the 0 comes second. If you're multiplying two numbers and one of them is 0, the answer is 0. That property actually turns out to be pretty important in algebra later on. Then there's the multiplication property of 1. Just like adding 0 to a number doesn't change it, multiplying a number by 1 doesn't change it. For example, 1 times 9 is 9. 6 times 1 is 6. It doesn't matter if that 1 comes first or if the 1 comes second. Either way, it does not change the number to multiply it by 1. So in A, what don't we like about that? We don't like that it says 4 cross for times and 1. And that's because we're going to be introducing x as an actual thing we need to work with, different from a multiplication sign as we move along. So the x just causes confusion when it's used for multiplication. But anyway, this is 4 times 1. Anything times 1 doesn't change the number, so this is 4. B, we don't have the x, we don't have the cross, we don't have a dot, we have a 0 and then in parentheses 5. Well, when a number is right up against parentheses, or in D, when parentheses are right next to parentheses, that means multiplication as well. So B says 0 times 5, and anything times 0 is 0. C means 1 times 52. Anything times 1 is itself, so 52. And D means 76 times 0. Anything times 0 is 0. And you can see it from just these examples. 4 times 1 would be the same as 1 times 4. 0 times 5 would be the same as 5 times 0. 1 times 52 would be the same as 52 times 1. And 76 times 0 would be the same as 0 times 76. Is it possible that there is a commutative property for multiplication as well? Sure is, and an associative property as well. Remember, the commutative property means we're actually moving them around. We're changing the order. 4 times 3 would be 12. 3 times 4 would be 12. For an associative property, we're changing the grouping. 2 times 3 times 4, it doesn't matter if we multiply the 2 times 3 first, or if we multiply the 3 times 4 first. When we multiply by the third number, we're going to get 24 either way. There's a third property. This one isn't exclusive to multiplication, and it wasn't mentioned when we did addition because it involves both addition and multiplication. It's called the distributive property. Specifically, the distributive property of multiplication over addition. So if we have a 2 times in parentheses a 3 plus 4, for example, that's the same as taking the 2 times the first thing and adding the 2 times the second thing. So 2 times the quantity 3 plus 4 is the same as 2 times 3 plus 2 times 4. And you might be saying, well, why don't we just add the 3 plus the 4 to get the 7, and then the 7 times the 2 is the 14, as opposed to 2 times 3 is 6, and 2 times 4 is 8, and 6 plus 8 is 14. Why would we ever want to do this? Remember, I mentioned that x is coming. And we don't know what x plus 4 is, but we still have to be able to multiply it by 2. So we need something like this distributive property to get rid of parentheses and problems. So let's practice. Rewrite 4 times the quantity 5 plus 6 using the distributive property. It would have been nice if that animation happened in the other order, but so be it. The 4 times the 5, and then add the 4 times the 6. We don't need to simplify it. We were just told to rewrite. Use the distributive property to multiply 3 and 79. Well, here's a nice use for it that doesn't involve this x that's coming. 3 times 79, that's a big number. We actually don't know how to do that yet. Right now, all we're assuming is that we know how to do the basic multiplication table. 9 by 9, maybe 12, but we're just assuming that you know through your nines. By the way, if you don't know through your nines, make flashcards, get those memorized. Math is going to get hard without being able to do your times tables. 3 times 70 and 3 times 9, those are easier to do. We can write 79 as 70 plus 9 because that's its expanded form. So 3 times 70, that's 3 times 7 with a 0. 3 times 7, we know that's 21. 21 with the 0 is 210. 3 times 9, we know that one, that's 27. We add 210, 210, sorry, plus 27, and we get 237.
Okay, 38 times 8. When we have more than a single digit times a single digit, our rule, just like with the addition, is that we're going to focus on the first column first. 8 times 8 from your table is 64. We're going to carry the 6 just like when we add it. Split it up, tear it apart. The 4 goes down here. The 6 goes up here. Remember that we put that 6 here. When we move on, we're now going to do this digit times the second one. 8 times 3 is 24, but then we add what we carried. 24 plus 6 is 30. $304. Let's do another. $721 times 6. Again, just ignore everything but the first column. All the way to the right. 6 times 1 is what? 6. Nothing to carry. Move over. 6 times 2 is what? 12. Split it up though, carry the 1. 6 times 7 is 42 plus 1 is 43. 4,326. Wrench. It's written horizontal, so we write it vertical. 613 times 8. First column. 8 times 3 is 24. Split it up. 8 times 1 is 8. Plus 2 is 10. Carry the 1. 8 times 6 is 48. Plus 1 is 49. 4,904. Okay, let's complicate this now. Instead of multiplying by a 1-digit number, we're going to multiply by a 2-digit number. Here's the rules for this. Ignore anything but the first column on the bottom and do this problem first. Do 56 times 4 first. Just like normal. 6 times 4 is 24. Put down the 4, carry the 2. 5 times 4 is 20, plus 2 is 22. So right here, we basically have the problem 56 times 4 is 224. Now, we're going to reveal the 5, and we're going to ignore the 4. We're going to cross out that 2 we carried because we're going to have a whole different system, a whole different group of numbers that might get carried. That 2 is not involved anymore. We're going to do 56 times 5, but notice the 5 isn't all the way on the right, so we're going to start putting our answer right here under the 5, but we're going to do the same thing. 5 times 6 is 30. Split it up, put down the 0. Now we're carrying a 3. 5 times 5 is 25, plus 3 is 28. So we have two answers here. One of them is 56 times 4. The other is 56 times 5. The one that's times 5 ends underneath the 5. So every row we have gets moved over 1. 4, 2, 0, 3. What did I do? I added these two things together. Lined up the way they are supposed to be. Nothing here. You can put in a 0 if you want. But 3024 would be the answer. Let's do another. 992 times 74. 4 times 2 is 8. 4 times 9 is 36. Put down the 6, carry the 3. 4 times 9 again, that's 36, but we carry the 3. Add that on, we get 39. We're going to move over and do times 7 now, which means we're going to start underneath the 7. 7 times 2 is 14. Carry the 1. 7 times 9 is 63, plus 1 is 64. Carry the 6. 7 times 9 is 63, plus 6 is 69. We're going to add these together. 8, 10, carry the 1. 10, 4, that's 14, carry the 1. 10, 3, that's 13, carry the 1. 1 plus 6 is 7. 73,408. And we could extend this rule with the lines multiple times. Let me find one that we can work on that's a larger number. Then we'll move on to some multiplication tricks that we can do with certain types of numbers. And by the way, the answer to a multiplication problem, remember, for addition, it was called a sum. For subtraction, it was called a difference. For multiplication, it's called a product. So when we are multiplying, we are finding the product. Let's do 8,646 times 354. 3 digits in the second one, which means we're going to have 1, 2, 3 rows going off this way. We'll add all 3 together to get our final answer. First, we do times 4. 4 times 6 is 24. Carry the 2. 4 times 4 is 16, plus 2 is 18. Carry the 1. 4 times 6 is 24, plus 1 is 25. Carry the 2. 4 times 8 is 32, plus 2 is 34. So this is just 8,646 times 4. Now we're going to move everything over a column and we're going to do times 5. We're done with these carry numbers. 5 times 6 is 30. Carry the 3. 5 times 4 is 20. Plus 3 is 23. Carry the 2. 5 times 6 is 30, plus 2 is 32, carry the 3. 5 times 8 is 40, plus 3 is 43. Oh, don't add yet. We're not done. It wasn't times 54, it was times 354. So now under the 3, we have a third row. 3, we're done with these carrying numbers. Let me actually erase those so we don't run out of space on the top. 3 times 6 is 18. Carry the 1. 3 times 4 is 12. Plus 1 is 13. Carry the 1. 3 times 6 is 18. Plus 1 is 19. Carry the 1. 3 times 8 is 24. Plus 1 is 25. Add these together. 4, 8. 8 and 8 is 16. Carry the 1. 5, 6, 7, 8, 9, 10. Carry the 1. 4, 5, 6, 7, and 9 is 16. Carry the 1. 1 and 4 is 5. Plus 5 is 10. Carry the 1. 1 plus 2 is 3. 3,060,684 is the answer to that one. Okay. 1947 times 2,039. Let's start with 9 times 7. That's going to be 63. Carry the 6. 9 times 4, that's 36 plus 6. That's 42. Use your fingers if you have to. Carry the 4. 9 times 9 is 81, plus 4 is 85. Carry the 8. 9 times 1 is 9, plus 8 is 17. We're done with those numbers. We move on to the 3 now. Start putting our answer here. 3 times 7 is 21. Carry the 2. 3 times 4 is 12. Plus 2 is 14. Carry the 1. 3 times 9 is 27. Plus 1 is 28. Carry the 2. 3 times 1 is 3. Plus 2 is 5. Let me double check that. 21, carry the 2. 14, carry the 1. 28, carry the 2. 3 plus 2, yep. Moving on to the 0. When we have a 0, 0 times anything is 0. So instead of putting a whole row of zeros in, let's just put in this single 0 to account for this placeholder and move on to the 2. Shortcut when we have zeros in the bottom row. 2 times 7 is 14. Carry the 1. 2 times 4 is 8. Plus 1 is 9. 2 times 9 is 18. 2 times 9 is 18. There was nothing to carry. Put the 8 down, carry the 1. 2 times 1 is 2. Plus 1 is 3. Again, I'll check this. The zeros from here. 2 times 7 is 14. Carry the 1. 2 times 4 is 8. Plus 1 is 9. Carry nothing. 2 times 9 is 18. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Now, technically, we do have 4 rows because this 0 is like that whole row that begins here, and then this 4, 3, 8, 9, 4 is technically the 4th row, but we have it pushed up. But again, if you end up with that, that's fine too. A whole row of zeros for that, and then move on. If that's how you have to do it, that's fine. 3, 3, 9. 19, carry the 1. 16, carry the 1. So I'm going to double check this with my cheating tool. I don't want to give you wrong information. 396 9933. I'm right. We did it. 3,969,933. Remember, I said that there's going to be some numbers that we can do a little shortcut trick on. And this is the shortcut trick. If we have 12 times 50, any numbers that end with a string of zeros, we could ignore and then add on to the answer at the end. So instead of 12 times 50, we can do 12 times 5. 5 times 2 is 60, or sorry, 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6, which gives us 60. And then we can take that 60 and add that 0 we cut off to the answer. 12 times 50 is 600. Seven times 800. We can cut off these 2 zeros, do 7 times 8 is 56, and then add those 2 zeros back on to the end, 5,600. We like numbers that end with 0. Easier to see. 3 times 100 is obviously 300, right? 3 times 1 is 3. Add on the 2 zeros, 300.
Let's talk about finding the area of a rectangle. This rectangle is 12 inches by 4 inches. So we've divided it up into 12 spaces going left to right, into 4 spaces going up and down. If we were to count every one of those squares, we would get that there's 48 squares. The squares would be 1 inch on each side. So we call the 48 squares 48 square inches. This is the same as multiplying the 12 by the 4. Repeated addition is just multiplication. 12 4 times is 4 times 12. 12 times 4. 4 times 2 is 8. 4 times 1 is 4. 48 square inches. So we can multiply the length times the width to find the area. The state of Wyoming is in the shape of a rectangle whose length is 360 miles and whose width is 280 miles. Find its area. Well, length times width. 360 miles times 280 miles. If we do that, we line up the 360 and the 280. 0 times 360. Get an answer. Move over. 8 times 360, get an answer. Move over. 2 times 360, get an answer. Add the three partials together, being sure that you moved over one every time. In other words, one placeholder 0 on the second row, 2 placeholder zeros on the third row, and you get 100,800. And that's square miles, because remember, our visual. That's how many squares there are that are mile by mile long. You also could have done 28 times 36, 36 times 28, gotten 1008, and then added on the 2 zeros that you left off. I think I'd prefer to do it that way, because you'll notice your first row was a row of all zeros when you multiplied it using 360 and 280. So if we have a rectangle, and this rectangle has a length and it has a width, or length and width, they're really interchangeable. We would add the sides. So we'd have another L up here, another W over here, and we'd go W plus L plus W plus L. And we'd have 2 W's. We'd add it to 2 L's. And that'd be perimeter. And everything was good. And now we have area, which is something else. And we have a length and we have a width. And the area is the length times the width. So for a rectangle like this, the area, when we have a length of 8 meters and we have a width of 5 meters, the area would be the length times the width. It would be 8 meters times 5 meters. And we're going to see 8 times 5 is 40. We're going to see that meters times meters is meters squared. We're going to talk about exponents in a little bit and see a little more why something times itself is called squared and has a little floating 2. But meters squared, otherwise known as square meters. What is area? Well, if the length is 8 meters, so each of these would be 1. So there's 8 meters this way. And this is 5. Each of these is 1. So there's 5 that way. And these are 1 by 1, which makes them squares. These are squares that are 1 meter long. They are square meters. And how much stuff is inside? That's area. Area is the stuff inside. If we count them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. There's 40 of them. 8 times 5 is 40. There are 40 square meters inside of this figure. Not meters, square meters. And they're called that because they are squares. We'll see mathematically it's literally meters squared, but for now, all you need to know about a square meter is that it's a square that's a meter by a meter, and it's the stuff inside. So area is an example of a word problem that requires multiplication. Here are some key words or phrases that also indicate that it's a word problem that requires multiplication. None of these should be particularly surprising. Multiply, for example, multiply 3 by 4 means 3 times 4. Product, the product of 5 and 10 is 5 times 10. And times, 6 times 4 is 6 times 4. A particular color printer can print 21 pages per minute. How many pages can it print in 25 minutes? In other words, 21 pages 25 times the pages per minute times the number of minutes. 21 times 25. We do 21 times 25. 5 times 21 is 105. Move over 1, placeholder 0. 2 times 21 is 42. Add the partials, 525 pages. A professor of history purchased DVDs and CDs through a club. Yes, this is something that actually used to happen in the past. And before DVDs and CDs, it was cassettes and cassettes. Each DVD was priced at $11 and each CD cost $9. He bought 8 DVDs and 5 CDs. Find the total cost of the order. So if he bought 8 DVDs, that means he spent $11 8 times. And if he bought 5 CDs, that means he spent $9 5 times. 8 times 11 and 5 plus 9. And then we want the total, so we'd add those together. 8 times 11 is 88. 5 times 9 is 45. Add them together for the total, $133. If an average page in a book contains 163 words, estimate, rounding each number to the nearest 100, the total number of words contained on 391 pages. So the exact answer would be the 391 pages times 163 words, because there's 163 391 times. Instead, it's a little bit easier, a lot of bit easier, if we multiply 2 estimates together, rounding each number to the nearest 100. 163 words rounds to 200. 391 pages rounds to 400. 200 times 400 would be 80,000. 8 with 4 zeros. 2 times 4 is 8. And then 4 zeros that we left off make 80,000 words, which was a lot easier to get to, but again, is only an estimate. And that's it for this topic.